Can we escape this universe? Age old question. Before I answer this question, let me give a very brief overview of dimensions in space. A point is a zero dimension or zeroth dimension. If we join 2 points, we get a one dimensional line. If we have two parallel one dimensional line and we join them like this, we get a two dimensional space or two dimensional box. If we have these two dimensional rectangles placed parallel to each other and we join them like this, then we get a three dimensional space or three dimensional box. The idea can be extended to get a four dimensional or fifth dimensional space as well. Now, coming back to our question, can we escape this universe? Let's talk about two-dimensional universe, which is kept inside an infinite two-dimensional sheet or a box that extends in all directions to infinity. Question is, can a two-dimensional creature like here escape this universe, escape this two-dimensional infinite universe? The answer is obviously no, because no matter what path this creature travels, it will always end up inside this box. Doesn't matter what kind of path it travels. Let me take another color pen, maybe black color. No matter what path this creature takes, it will always end up inside this box because box extends to infinity in all directions, in two dimensions. The same idea can be extended to our three-dimensional universe. Our three-dimensional universe can be hypothesized as space inside an infinite three-dimensional box. I have drawn that box in red color. There is only one way that we can escape our three-dimensional universe, and that is by discovering some kind of new fourth dimension in space. This new fourth dimension will technically be perpendicular to our existing three dimensions that we have in space. If you have followed so far, let me ask an open-ended question about this idea. We know that gravity in our three-dimensional space varies as inverse of the distance squared. The question is, in a two-dimensional space, how will gravity vary with distance? And similarly, in a four-dimensional space, how will gravity vary with distance? Will the variation remain same as g inversely proportional to 1 over r square, or there will be some mathematical changes in this expression? If you have liked this video, don't forget to subscribe the channel and share this video with your friends. Thank you very much for watching. Have a very nice time.